So I'm recording now. So, same rules, I guess, apply to faculty. If you want to ask a question and you don't want to come on the microphone, we can type in the chat. I'll check the chat and share with the speakers if you're so inclined, right? So just before we get started, I put a whiteboard up here to just share some information with everybody. This is our first brown bag seminar for the semester. Georgina was supposed to actually speak in the spring, but of course that didn't happen. So she's speaking now, and then Kat Griffin, who was also supposed to speak in the spring, will be speaking at the next event, right? So just a couple of reminders, if you are doing undergraduate research with students, we did send out a survey through Office of Academic Affairs and also the reps, just to find out how you've adapted, what challenges you're facing adapting to the online environment. So it's a really short survey. For those of you that have done it, thank you. For those of you who have not, if you could please do that by Friday, that would be great. All right, our next brown bag is going to be on October 21st, and that will be Kat Griffin and Mercedes Franco speaking at that event. And then Olga sent out the announcement through OAA this morning, but some of you may already know we are going to have a virtual undergraduate research day. Still working on the logistics of that, but something will be occurring. And the date for that is Friday, December 4th. So you'll be getting more information about, say, deadlines of when things are due and what the format's going to be as we're putting that together. All right. So let me get off my share screening here, and then Georgina, you should be able to share your screen now. Hi, everybody. I see a lot of people have arrived since.
Where are you, John?
Where am I? I'm here. Oh, with my background here, this is my daughter's college. It's such a beautiful picture. I decided that I would pretend I was there instead of my dining room table. Yeah. Yes, that's Middlebury College in Vermont. So Georgina looks like she's ready to go. So let me just give a brief introduction. Georgina Colalillo is a professor in our nursing department. She's been for 12 years a project director for the Perkins Grant in the nursing department. She's developed and she directs a mentoring and peer mentoring program and established the role of a student success advocate in the nursing program. And she's also developed an evidence-based research project with dual joint scholars and serves as a resource in leading the faculty and mentoring nursing students in research. She's been our nursing department rep to the research committee, I think, since it began. Maybe 3 years ago, maybe more, I'm not sure. But so welcome, Georgina, and whenever you're ready, go ahead and get started.
Okay, first of all, thank you for having me. I'm, happy to present a project that's very near and dear to my heart. So here we go. All right. Whoops, sorry. Now I got to go to that. See, this is the problem with this. I don't know how to work this. Just start all over again. All right, here we go. All right, so why research in nursing? I'm going to speak to you about an evidence-based research project that I began about, I want to say 6 years ago, when we began to have our dual joint scholar program. And I'll explain to you what that is. So why research in nursing? Well, in 2001, the Institute of Medicine found that there were unacceptable gaps between what practitioners know and what they actually do in the care of patients. So what evidence-based research is, it's the ability to translate to practice, and this can close the gap and enable nurses and other healthcare providers to make informed decisions so that they can deliver the highest quality care. So that's really the basis of why I started this project, because our students need it. And if we don't have it, we can end up like this patient. So that's why I began this project, because we may have all of the knowledge, but in order to really look at different research and vet research and assimilate that knowledge into best practices in a way before we get to the bedside and have that. If we wait till we get to the bedside, then we're going to end up like this and someone's going to suffer, and it's usually the patient. So the rationale for implementing undergraduate research in nursing in our program is because we didn't have in the nursing curriculum a formal research course. How research gets integrated is in each course separately by the faculty member teaching the course. And we do integrate it. There is it's one of our competencies, but it gets done in a very informal way. Is that me? Sorry. Does anybody hear that except for me?
Yes, hi. I received
I can hear and also hear
voice
it.
message today that something is being delivered, but I need to confirm if I'm going to be home or not.
Oh, it's somebody talking. I'm sorry. I thought, okay. Should I go on? Okay. Okay. So, and another reason why is because evidence-based practice is a core nursing competency. It's one of our 8 competencies. The nursing curriculum also has 2 writing intensive courses in the 3rd semester and the last semester, NU 201 and NU 204. So these are great springboards because this writing can be translated into a research project and then also be presented. So students have time to prepare for a research project. Students progress as a cohort and can complete a project over 2 semesters. That's another benefit that we have in nursing. And research skills are beneficial to academic progression, which our students need to do, securing entrance into an internship fellowship program after they graduate, and for achieving magnet status, which all healthcare organizations that is their goal. So it really helps our students to be able to be practice ready, workforce ready, and have the skills that they need. And this is one of the skills that they need. So this project is really not integrated into any one particular course because we do not have a formal research course. So how it's integrated is with the dual joint scholar program. And I'm going to explain that. Oops, did I skip one? Maybe I did. How do I go back? Does anybody know how to go back? Oh, here we go. All right, so we have 3 dual joint partnerships currently that exist. Hunter Bellevue School of Nursing, York College, and School of Professional Studies. This means that once selected, the dual joint scholars seamlessly transition to a baccalaureate in nursing. And that is the mandate now since 2018, the end of 2018, the BSN in 10. Okay, so the number of dual joint scholars that we have currently in fall has grown tremendously. In the second half of their education, which is a second year student, NU 201 and NU 202, we have currently 73 students. Just accepted and enrolled this past spring 2020, 57 students. So we have about 130 students currently in any one of the dual joint programs, and that's about 45% of our students. And we're not going to stop till we get almost 100%, and it's really a tall order. They have to apply, they have to qualify, their grades have to be good enough to meet be able to be duly enrolled. So they begin at Queensborough, and once they get the dual joint status, they continue their education at Queensborough, graduate, they take their NCLEX, which is their licensing examination, and they seamlessly, that means they do not have to apply, transition to their senior school, which is one of the 3 CUNY colleges. Now, our other students can just do a transfer where they graduate from Queensborough, take the NCLEX, and then apply to any other BSN program. And it doesn't have to be CUNY, but we think that CUNY has the best value, best bang for the buck, so we always kind of recommend. But our dual joint students do not have to apply. So they were already accepted by the end of their first semester in the nursing program. So this was a good group to work with because they were already engaged in their dual joint status. They're motivated to be able to understand what they need to do when they transition. And one of the things that the senior colleges asked is that students have some research skills when they come. So that was my goal, is working with the dual joint scholars. So this is the process. In the fall semester, there's a call for abstracts and proposals, and this is distributed to all dual joint scholars, especially if one of the senior colleges like Hunter Bellevue School of Nursing usually holds a research day in every spring. So we always know that we have that venue. And some of the other colleges also will send a call for abstracts. Then I will go ahead and recruit faculty mentors. And I never really have a problem. Faculty love to work with the scholars. And then I organize the student scholars into groups of the faculty members. Now this happens, they might request to ask to work with a group of students who have similar interests, or maybe if faculty has a certain interest and they put that out there and students say, yes, that project sounds interesting to me. So it happens both ways. The students get to choose what they want to do. We don't like cubbyhole them into, forcing them to do something. We want it to be interesting to them. We want them to be motivated to do it. Then in the spring semester, there's a series of meetings with faculty members and the faculty mentor and the scholars to develop the research proposal, the abstract, and to decide how they want to create their poster. There's the submission of the abstract, and that usually happens in February, March. Then we have to get the response. Was the abstract accepted? And sometimes we have to make some corrections on the abstract, and I think that was also a good learning process for students and faculty, also. Then they develop and submit the completed research poster, and they print the posters out at the senior college, or we can have it printed at Queensborough. I don't know how that's going to work with COVID, but we're going to see how that works. And then they actually go to the venue in usually April of the spring semester and present their research project. Usually I try to limit the groups of students to anywhere from 3 to 6 students per faculty mentor. That seems to be manageable for the faculty mentor, and it also seems to be manageable for the project. And it gives enough items and enough of the research to do for students. I don't want students just putting their name on the poster if they really haven't participated. So every student has to have a job. So we usually use the steps of evidence-based process to kind of help our students to develop their project. They ask a clinical question, and remember, our students have been going to their clinical sites or their healthcare organizations for at least 2 semesters. So they get a good look, see what needs to be improved, what needs to be done, what's not working in the clinical area. And so they start to ask, why can't we do it this way instead of that way? And I love when students ask that. So they ask a clinical question. Then they're going to search the published literature to see, what's new with that clinical question. Then they need to appraise the articles. And I did develop like a little chart or rubric where they can praise the articles. I do share that with the faculty mentors. Sometimes they choose to develop their own. I like the students to do a process where they do a stepwise process. So it makes it easy for them. They learn better, they understand what they're doing. Then they integrate their findings they're not integrating into practice, they're integrating it into developing their research poster, into seeing, can this be integrated into practice? We don't really get to evaluate the results. We would have to get an IRB for that and really institute our project. So we don't always get that far, but there are some faculty members who have projects that have been ongoing for a while, who may be able to get students involved with collecting the data for their project. And I definitely encourage that. And then they would have to get an RB for that. But we don't always have to get an RB if we're just doing the initial stages, which is the literature review. So that is an option. I don't want faculty mentors to think that if they can't get an RB, they can't participate as a faculty member, mentor. They can. They just need to, you know, create it so that the students can do a literature search. And that is also learning. And then they can decide if they want to take their project to the next level and get an RRB and then actually, you know, put it to the test. The last step, of course, is to disseminate the findings. So we kind of disseminate the findings of our literature search. The other way that we can do is this cyclic process of ask, access, appraise, apply, and assess. That's another way that we can look at evidence-based process. So they do have, when they're writing their proposal, they do have 3 formats to choose from for the project. They can do the actual research. That would include getting the IRB. And like I said, I definitely encourage it, but I don't want to discourage students from doing the project because maybe they can't get the IRB, maybe they're not going to be able to collect the data, maybe it's going to take them too long to get to that process. So we don't have to do format A, but that would require getting an IRB. Format B also requires getting an IRB. This is more of a clinical or programmatic or policy intervention. Students don't always choose this format. The one that they choose really works well with them. It's the format C, which is the literature review, okay? And I like this. Students start to understand the beginning of the research project in doing literature review, which is the basis of any research. The other thing that I like is they have to write an abstract and they have to limit it to 250 words. You know how hard that is for students, especially a group of collaborating students? They have to learn editing. And I think this teaches them really how to really look at the critical pieces of what they have to submit for their abstract. And sometimes they tell me, oh, Professor Colalillo, that was the hardest thing that I ever did, editing it down. And I think it's a learning process. So, and they like it because it helps them in their writing. Okay, so how does this project align with our program's objectives or our competencies? Well, it aligns with all of them. Okay, these are our, is it 8 or is it 7? 1, 2, 3, 4, 5, 6, 7. Yeah, we went down to 7. Actually, we have one more, it's assessment, so it is 8. But it does align with assessment because they have to assess the research, so I should have put it in there. So what professionalism, they have to write professionally and write an abstract professionally and present at a professional research conference. That's how they fulfill that requirement. Safety, all of our projects are related to safe care of the patient, safe and effective care of the patient. Evidence-based practice, I guess that speaks for itself. Patient-centered care. Well, you can do all of the research and you could try to apply it to a patient population, but if it doesn't meet the patient's needs, values, and wants and desires, then the research is no good. So we bring in culturally competent care, like who's going to accept this kind of care or this kind of intervention. So it really is very, very interesting, and they can go off on all different kind of trends when we think about patient-centered care, but that's very much embedded in evidence-based practice. The patient or the community or the patient population has to accept the intervention. Teamwork and collaboration, well, they work in groups of 3 to 6 students with a faculty member, and they have to learn how to cooperate. They have to learn how to make a schedule. They have to learn how to develop a workload for each student. So it's really good, and they have to rely on each other for submitting the abstract. Quality improvement, that's what we aim to do, that even if we have something in practice that works, how can we improve it? How can we add to it? So we're always looking to improve projects. And informatics, we're doing a library search. We're using PowerPoints. We're using, creating a poster. That's all related to informatics. We're also, in this COVID world, we have to now adjust to meeting virtually, meeting through Dropbox or Google Docs. So they've really learned a lot of things, because last year when we weren't able to present, we were actually able to create all of our abstracts, and we all got them all submitted and accepted, but the presentation went to virtual. And so for some students that kind of like stymied them, like, well, how am I going to submit my poster virtually? How am I going to present virtually? So we gave them the option, if they still wanted to present, they had to contact the contact person at Hunter Bellevue School of Nursing and let them know that they were still interested in presenting and put their name as a presenter. And some of them did go ahead and present their project. Some were too busy and were just trying to get to, pass their course and couldn't do it. So we gave them the option if they wanted to still present, because they did put the work into their abstract. So that was very interesting. We did have some presenters, so I was glad. And the faculty member, of course, had to really assist them. So the goal of the whole project, if you want to think about overall goal, we want to empower our nursing students to use the research and to use evidence-based practice to improve nursing practice. And we want to prepare them for translation of research into practice. Currently now, it takes about 10 to 15 years before research is actually translated into practice. So we have to start the process. We can't wait till they graduate, can't wait till they go to their senior college. So that's my goal. So any questions?
Okay, I'm going to type my question here. I type it, can you read it, and maybe you can try to respond to me?
Okay, I'm gonna try. Wait, let me just
okay, chat box here.
See how to.
All right, it's a little bit really long, but yeah, if you can.
I'm gonna look at the chats, right? Oh
yeah.
boy. I'm trying to get my screen back. Let me see.
I have the chat here. I can.
Okay, you can tell it to me.
Maybe. Do you want me to read it to you?
Yes, please.
Okay. So Rex's question is there any chance for pre-nursing students to be engaged in some research? I know there are some students who keep applying to join the nursing program, but are unlucky to be accepted despite meeting the qualifications. I understand the QCC nursing program does not have a waiting list such that students must keep applying.
Well, we don't have a waiting list. That term went out a long time ago. How students apply is they have to meet the grade, qualification, or finish all of the courses that need to be finished before they come into the nursing program, and take the admission exam. So we don't really stop students and say you can't get in. As far as if they meet the qualifications, that's the basis. They have to meet those qualifications. And if you want to know them, I could send them. If you send me an email, I'll send you the qualifications that we have. It's also on the nursing website. But as far as the pre-nursing students, we do have some pre-nursing students that contact me that do want to present, and they actually could present at the undergraduate research day at the college. If they are enrolled in a course that, a faculty member would kind of work with one of the nursing faculty, and we can kind of work together to get that student or group of students to present. So yes, of course, they can. The only thing, they would not be able to present at these senior colleges, because in order to present, you'd have to be the duly enrolled student. So, and you'd have to be a second year nursing student. But as far as getting them on board before they come to nursing, I am all for doing that. So if anybody's interested, but I would need the help of the other faculty members that are willing to work with me.
That's good to hear, because such students, I'm told that they are told to remain active students by taking any other course. So I was thinking, instead of taking any other course, why can't they be involved at that stage? Because they kind of like waste their time, you know? So
Well, I think they would still have to be enrolled in some kind of coursework at Queensborough in order to be able to qualify to present at Undergraduate Research Day, right? I mean, again, I think they would have to be enrolled and working with a faculty mentor. But the faculty mentor can work with, you know, nursing faculty as long as they have some kind of, you know, coursework that they're tied to. So it can be done in English, an English course, a literature course, if you're looking at maybe the Common Read, or it could be done in a psychology course. I've had students present that, you know, said they were a pre-nursing student, as long as they have somebody else to work with.
Oh, and then the courses do not have, are they credit bearing? Like, do they have to take any other course apart from the research course? Or is it like independent work?
No, well, the thing is, they have to, in order for them to present at Evidence-Based Research Day at any of the different venues, they would need to be a nursing student, a dual joint student, enrolled in any of the dual joint programs, and they would have to be in nursing coursework at the time. They don't do it as part, they don't get graded as part of the course. You know, we don't grade them. So like, we don't say, okay, you're going to get extra credit in your nursing coursework because you presented a project. But we tell them that this is just necessary work, you know, for their future. And that's, I guess, is motivation enough to make them want to participate.
All right, thank you so much. Thank you.
So just following, I'm going to go back to Mangala's question, but just as a follow-up to that, if they do research in other courses, is that like considered when they do apply to the program?
Oh, yes, yes. Yes, they should, there isn't like an application, and they do come in and speak with someone. We do a one-to-one, like, you know, we'd like to hear what the student is doing. They should definitely mention that they've done research. We got a lot of students, some of our dual joint scholars have done research in other coursework. And they are our students who are like our champions. They get the other students involved, like, oh, I did it in my biology class, I did it in my psychology class. But they could let us know. That's one of the pluses of coming into the nursing programs. We would consider that the student is very interested in that. So that's a great question to ask.
Good, that's good to know. All right, and then we have a question here. Can you give examples of some of the research projects?
Okay. Well, we sometimes we're a winner. We looked at one semester. I'm going to say that one of the projects that I really loved, and it had a lot of bang for its buck. I'm trying to think of it, who was on there, but I might not be able to do this. We looked at screen time. There was a big, nobody was paying attention to what is acceptable screen time in children. You know, we were hearing all of these things about the negative effects or impact of too much screen time in the pediatric population or with children. But nobody was, you know, really writing about, you know, how much is too much, how much is acceptable. So we had students look at the literature. What does the literature say about screen time in the pediatric population? And they were able to look at the statistics. They were able to look at, you know, was there any established best practices? Has anybody done the research to look at if they did 3 hours of screen time versus 6 hours of screen time? What was the impact? And there was not a lot of research out there with that. So we actually did the beginnings of the literature search for screen time best practices in the pediatric population. And that was actually one of the projects that was selected as a winner because nobody was really looking at that. What else did we do? I mean, we've had so many great winners. We tested some we looked at some products being tested in the research of some urinary diversion, urinary catheterization, external urinary catheterization products for patients that do not cause infection. We looked at some of the newer products. We looked at safety, like we looked at swabbing the ports of the IV intravenous lines. What is the best practices of doing that? Because students do this so often and they never really question anything. Should we swab for 30 minutes or 60 minutes? Is there a special solution that works better than the next? So a group of students did that. That was actually a very good project, because sometimes we take things for granted that because we've always done it, it works, but we're finding that we're still getting infections. So maybe it doesn't work.
Right, good point, yes. Very interesting, Georgina.
Yeah, and they picked the project. My students asked a clinical question yesterday that I found very interesting. We're still, because we're in the clinical area, and I'm so glad we're in the clinical area, because with COVID, we're seeing different things and we're starting to question different things. So in the clinical area, I was asking the students, what's the best method or the measurement of taking a temperature in a patient? Is it oral, axillary, rectal, tympanic, the ear, scanning the forehead? And the students could ask that question. And I said, well, let's look at what we have, what we're taking the temperatures. When you get screened to just come to the clinical area, you just put your forehead in front of a little screen and it's saying, yes, go ahead. So we have all of this great technology, yet we're still resorting to, these traumas, because I'm in pediatrics right now. Imagine going to a parent and say, I have to do a rectal temperature on your child. Your parent should be asking, I just came in through the turnstile and they took my temperature with a screener that didn't even touch my forehead. Why can't we do that? So I said to the students, let's do the research. Let's look at temperature measurement and why we're still resorting to this. Is it accurate or is it not accurate? And if it's not accurate, why are we letting all these visitors coming to the healthcare facility if it's not accurate? So that's my question. So let's see if they take it to the next level. I'm hoping they will.
Yeah, that's a right.
It's the questions we ask every day. If we
I
have the
that question
technology,
all the time.
right? If we have the technology, does it work? Maybe it doesn't work. Who's doing the research? How many people are coming through the turnstile after getting their temperature read? How many of them are really having a fever versus how many don't have a fever? Is it an accurate assessment? And if it's not, why are we using it? That's what I say to students all the time.
Yes.
Do the research. So hopefully they will.
Yes, I'll be interested.
We'll look for that in our next project.
All right, thank you, Georgina.
Okay, thank you.
Stop sharing your screen and then Dugwon can come on and.
Okay, how do I do that now? Okay, good.
Just hit stop share. Yes, Dugwon should be ready. Thank you again. That was great. I'm giving you some applause here. Very interesting. It's good to know what our students are doing after, we see all of your students in our courses in bio, right?
Yes, I love seeing them. They're always motivated.
I know, yeah, Randall had students present.
Yes, we have a lot of faculty. He's been a mentor for a research mentor for a long time. So I got my mentors and then I have the ones who want to buy in. So it's great.
Fabulous. All right. So Dugwon Seo is next, and let me just introduce her briefly. She's an assistant professor in the engineering technology department at Queensborough. She has a PhD in civil engineering with a concentration in water resource engineering from City College, and she has a background in electrical engineering as well from her bachelor's degree. Her research interests are in the applications of remote sensing technology for modeling land surface processes, numerical weather predictions, and global climate models. She's also involved in research with machine learning and data science and about water resources in New York City. She's been mentoring for over 10 years, teaching and mentoring students at various levels. She mentors undergraduate students through our CRIS program and an REU, Research Experience for Undergraduate program. She mentors Hispanic PhD students through an NSF-funded HAGEP program. I'm not sure what that stands for. You'll have to tell me that later. And she's contributed to an increase in the number of women students in technology disciplines through a Women in Technology grant funded project as well. And so the title of our talk today will be Climate Change Research with Remote Sensing Technology. Dugwon, take it away.
Hi, thank you, Joanne. Hi, everyone. First, I would like to also thanks for having me and giving me the opportunity to talk about the research. I just realized I gave my introduction too long. So yes, today I'll just generally talk about the research I did before, and which is climate change related using remote sensing technology. So I just wanted to start with my background. As Joan introduced me very nicely, I have a civil engineering degree, but there are a different branch. Many people just have a civil engineer as a structural engineering, but my concentration was in water resource engineering, and I also have electrical engineering of telecommunication concentration background. So today, it will be more scientific research, talking about I worked in this research center called the NOAA CREST Lab. It is National Oceanic and Atmospheric Administration Center for Earth System Science and Remote Sensing Technologies. We have a mission to understand and predict changes in Earth's environment and to conserve and manage coastal and marine resources to meet nations' economic, social, and environmental needs using remote sensing technology. So let me start with explain what is remote sensing. So remote sensing is the process of detecting and monitoring the physical characteristics of an area by measuring its reflected and emitted radiation at a distance. So typically we're only talking about the satellite or sometimes aircraft. So special cameras or sensors collect remotely, sense the images, and we do the research with that, particularly of the Earth. So we call this a satellite, Earth Observation Satellite, EOS. And believe it or not, there are many satellite missions out there to observe different type of the Earth parameters and studying about the Earth. So the theory behind that, like what do you mean, like what kind of sensors, like what does that detect? So all the objects with a temperature above absolute 0 Kelvin reflect and emit the energy. By having a solar energy into the Earth will emit out the energy as a certain form. And this certain form that I'm talking about, the radiant energy, it has the electromagnetic radiation, which has the spectrum. So-called this electromagnetic spectrum has different range of the wavelength, from radio of the long wavelengths to gamma ray of the short wavelengths. And each range, it depends on the application. You probably are more familiar with the name as radio, microwave, infrared, visible, ultraviolet, X-ray, and gamma ray, those names. So we all know that has a different wavelengths. And it's using that a different wavelength, we can detect the different parameters of the Earth. So for example, the first graph shows just simply the difference between vegetation and water. So I'm just trying to see if I can point out the range between 0.4 to let's say like 0.7 micrometer. That's the visible wavelength range, which doesn't have much of the the difference between vegetation and water in terms of the reflectance. But after the 0.7, like a little above that, it shows the huge difference. So we can clearly detect the difference between vegetation and water. Likewise, on the right corner, the right side of the graph, it even shows the many different type of parameters. For example, like snow and ice, and clouds, dry soil, wet soil, the vegetation. You can also detect what type of vegetation, the health status of the vegetation, and the water quality on everything. Like, so many things can be detected by using the electromagnetic spectrum in different range with respect to the reflectance. So what do we observe using satellite on Earth? So these are just a few examples out of many, many applications. So as you see, the first, the left corner, upper corner is detecting like a wildfire, for example, using infrared wavelength. As we know that California is still suffering from this wildfire, which is the result of the climate change. By the way, the wildfire cannot be managed by forest management, if you know what I'm talking about, by yesterday's debate. That cannot prevent either drought or the dry air. So also, it can be detected the topography of the Earth. In fact, this is being used by technology of active microwave. So it just worked like a laser. Instead of just reading the reflectance, it shoot out the signal and receive the signal back and calculating the time and distance to come up with this shape of the topography. Like see the temperature and global wise or the hurricane. So this is just like representative applications that everyone can be really familiar with, but there are many, many applications. My expert on this using remote sensing is in land hydrology, since I studied the water resource. So when we in hydrology, when we try to estimate the water amount, we use this model called the water balance equation, and which has certain parameters. And soil moisture is a very important parameter to estimate the water balance. And on your right side, using this satellite sensors, if you detect the soil moisture data by satellite, we can apply that on the water balance equation. I'm sorry, basically how soil moisture is being estimated is using microwave emission radiative transfer model. So this is by model, but if we get the data by soil moisture, you can apply to the global wise without limitation of the time or the location. And that's why we are using it here in land hydrology. So just to explain why soil moisture is important, because its variation influence the evolution of weather and climate. And it works just like a sponge. Once there's a precipitation, it absorbs the amount of the water, and it can directly affect the atmosphere of the weather. Also, it controls the runoff of vegetation growth, evaporation, and transpiration. Typically, the soil moisture data can be collected by ground-based measurement. Just literally, you pick the site and you dig the ground, and by different level, you can collect and measure the data. There are a few of those ground-based measurement site on the US. Also, you can use like hydrologic model, like putting that data onto that just to estimate. But if you use the satellite-based observation, like I said, it will not be constrained by the regional or the temporal scale of the limitation. So then how would the satellite sensor will detect the soil moisture? The soil moisture, so since it's the water contents, so it has a dielectric characteristics, and between dry and wet soil, it has a different content of the water. So the range between 80, let's say 80, from 5 to 80. And using the electromagnetic spectrum of a microwave, particularly low wavelengths, the short wavelengths. And within the microwave, we can categorize by like range again, and we named with a band. And for soil moisture detection, the L band is being used because it has a longer penetration. It can penetrate the atmosphere and then reach to the ground. So considering all of that, there were many missions just particularly designed to detect the soil moisture. And the time I was very actively working on this research, which is after like 2010, there are two major missions that has L-band and particularly designed for the soil moisture detection was SMOS and SMAP, those two missions. The one is from the NASA, US NASA agency, and then the other one is the European the Space Agency. By the way, these missions, mostly they are, the research that are done by federal government agencies such as NASA, NOAA, or the USGS. So there are many researches that are going on. So yes, the L-band of that particular wavelength is being used for the soil moisture detection. It can reach up to 5 centimeters of the depth under the ground. So my research was just getting the soil moisture data, and I just tried to validate the model and approach that model, and also for the application using those two different missions. So one of the application is the flash flood forecast. And like I said, knowing the soil moisture, you can estimate how much soil can hold, how much water the soil can hold, and shows the flood forecast, for example. So this is what I've done, and still I'm kind of engaged with the students to work on this research, but I just giving a concept to the students, it was like a little bit advanced. And I actually last year I worked with the student in CRISP program on this project, but I realized the student was kind of feels too heavy. So I learned from, like experience, like I should, I'm thinking of different project too, and list the current topics that I'm interested in is like machine learning or data science, because using satellite data, it collects the global scale of the data. And even in temporal, they're providing and prepared a big data, and maybe we can use the machine learning or data science technology to do a different type of research. I'm also interested in a 5G network, which is a little different, but it's still the using the electromagnetic spectrum in particular frequency and wavelengths. And like I said before, and I was also working on the promoting women students in technology project. I'm trying to teach women students with different like computer skills and technology related knowledge so they can be more interested in this field. So I just wanted to just talk about general idea of this remote sensing research. I will, if you have any question, I can answer it now. Thank you.
Thank you, Dugwon. Very, very interesting. I see some, environmental science collaboration possibilities here. So you and I should talk. I have a question. I'm interested in you talked about applications in terms of flash floods. What about predicting drought or drought conditions, or possibly in some way then seeing when flooding will occur and collecting water somehow to alleviate drought? Has there been
Yeah, absolutely. Well, how I see is that flooding and drought is actually, the same concept because it's the two different extreme cases. So yes, by like studying the soil moisture, that can also apply on a drought, which can be applied in the agriculture field as well. So definitely that can be applied using the remote sensing.
Mhm.
I have a question. When you do your research, do you come across political issues, debate issues regarding climate change when you work with your students or when you teach this subject, or maybe when you are given like a mini presentation on climate change? Do you come across this debate, a political debate of whether there is climate change or not? You come across this, and how do you deal with it?
Well, so yeah, I do mention it in one course that I'm teaching. This is actually the course is about the renewable energy, in which I can make a connection with the climate change. Then, well, I don't know. Like I'm only approached by the scientific facts and the evidence, and I can debate that the climate change is supported by the data. I'm not sure if that's what you're asking.
Yeah, that's it. That's what I'm asking, because I've been invited a few places to share my ideas on climate change. And looking at the nature of science, well, I have to defend my part. I have to do it. But it's still here and there, it tends to be too political. And also, it's about, some people say I believe it, I don't believe it. So I have a hard time sometimes to do my part. So I wanted to see how you handle it yourself.
Yeah, well, but I would say that science answers more strong than political reason. I don't want it to involve with too much in political way, but I'm a scientist, I'm an engineer, so the best thing I can do, I teach students to that too. Like once you have a lot of fact and knowledge that you can support yourself, nothing can beat that. I don't know if anybody else have input on this.
I know many people will try to say, no, I don't want to do this, it's too political, but the subject itself, you can't run away too much. At one point, you have to say, talk about it and also defend whatever you think about it. But I know most of the time, let's not do politics, but it will come up because we are just by nature political people. We are people. We have to talk about it.
Yeah, but we have a lot of data. We can just keep on showing with the data, the fact, and a lot of researches. These people, if they're more aware, that I believe that's my job. I'm teaching students with the data support, and they get it. Like students, they're here to learn, so they get it. So I think showing data, the scientific fact, that will support you your
Exactly, I agree. I guess the question becomes awkward when you are teaching this and it comes up in class. Yeah. You just have to be ready how to defend yourself there. Anyway, that's it. Thank you. Mm.
Okay, any other questions for Dugwon? I find it's sad that we do have to defend ourselves so much. So Razan is typing something here, including politics in the classroom might not work out, but we can demonstrate the science behind it and create critical thinkers. We have accomplished our purpose. Yes, that's, I agree completely. Our job is to, get them to be able to think and evaluate information that they're hearing, and hopefully, make a sound judgment based on fact, not whatever else people have been basing their
Yeah.
opinions are. That's a really good point.
Mhm.
I think, just my opinion too, is that scientists don't always do the best of jobs at relating information in a way that the general public can understand, and that becomes part of the problem. And we don't understand it, so we're just going to have to ignore it or whatever. So that's a piece of it too. It's just getting proper science communication out there in such a way that it does make sense. All right. Any other comments, questions? This was very interesting. Okay, we have a question here. Can you talk a little about how remote satellite data might be used to track fires, such as what's happening on the West Coast?
Yeah, so this technology can be used for like monitoring purpose, for example. So it doesn't have a limitation because I mean, I haven't been to that area, but I'm sure there are large area of the mountainous area. So you can't just by human, you can manage that like one by one. But from up there, if you can observe, and fire is the higher temperature, so they usually use the infrared sensor. So you can monitor, and if you can find out, if you can specify the location where it's starting to like spread out by detecting the abnormal temperature, then it can be response to like a faster response to extinguish. That's how I would see that the application can be done for the wildfire. Yeah, but based on the nature that dry air, extreme dry drought, and with the wind, and if it spreads, it spreads. But if the monitoring, like to detect it the early stage, that could be somehow it could be helpful. That's my answer to Joseph. And the other question is great.
I don't see any other questions here, but just some comments about, nice to learn from everyone of different disciplines, right? Always good to know what's happening in other fields.
Mm-hmm.
And it's good to know. So your research, I guess, using these data that you're collecting is COVID affected or not COVID affected? I'm very interested in finding out how people have adapted to research without being able to meet students.
Right. Yeah, well, since this just, we can, the data is out there already. So without just pure research itself, the COVID was not like a big effect. But, like mentoring students, the students, they need some interaction with the mentors. So those, yeah, definitely I can say that in terms of that is being affected. But otherwise, there's no direct influence for the research itself. but I'm not like currently doing this research very actively because I was tied up with the other projects, but I will always look for the collaborative opportunity with a different discipline in like data analysis or environmental science, just to to have different applications. So if you are interested, I'm working to have a conversation for further opportunities.
Great. So a couple more questions here have come up from, does the monitoring have any venues of approach to intervene into the situations? So you're detecting changes in moisture. Is there then a piece that goes with that for intervention, I guess, is the question?
So if you're talking about the wildfire itself, I'm not very familiar with that because that was not my application. But if you're talking about the general, like for example, which always trying to improve the model for, let's say, the weather forecast. Having the more wider range, just like a data science or the machine learning, if you have more data, it helps to determine a more accurate decision. So likewise, if you have the global way or more time divided data, that can be helpful to simulate the model and have a better prediction. So like my case for the soil moisture part with the water balance model, with more soil moisture data putting in the model, it will help to calibrate or to elaborate the model to give you better prediction of like flood forecast. Yeah, for particularly soil moisture, yeah, it can be applied in the flash flood forecast. But if it's other than that, you know, there is a scientist who work on the atmosphere, the weather model. I'm sure, like compared to 10 years ago, the weather forecast model has been like, you know, relatively better than 10 years ago or 20 years ago. And I believe that's because of all the researchers continue to have a better result. Yes.
Okay, and then one more question from, do you work mostly with graduate or undergraduate students?
So, like I said, I tried to work with the QCC students, but it was kind of difficult. It was very challenging for me because students didn't have any background knowledge yet. So they need some physics background and certain backgrounds. And mostly when you deal with the data, you will have to have a computer programming skills. So even in senior college, I guess, you know, by second or third year, they'll be like comfortably to do the research as an undergraduate students. So now I'm in like position of a little bit trying to have a little lighter project topics so I can work with QCC students here. So in this project, yeah, there are more graduate students, but since I'm here, I will try to, I would like to work with the QCC students. So I will work on that to have a lighter project topics.
I have a question. So what type of data analysis software were you using when you were working with the student?
Software.
Or maybe it wasn't the software. I was just wondering what was the thing that was so advanced that they had, you know, they were struggling with for the data analysis?
I see. So first of all, the computer skills I use the MATLAB, and now students are like free to use any different type of programming. So I see that the newer generation, they use Python and apply to the MATLAB. So those things. But in terms of the concept, so just to introducing the electromagnetic spectrum part is the part of the physics. And I work with a student who's currently taking up physics at the same time. So he kind of get it, but I just didn't want it to overwhelm the students.
Yeah, it seems like it requires a knowledge of a broad scope of different
Right.
topics, right?
Yeah,
Which is hard to do at our level.
Even politics, yes, like I was asked about the political issues, but yes, it is. Or sometimes we also use the GIS software because we wanted to apply whatever we found out as a result to put it on top of the map. So having GIS skills also being helpful and have a great output as a result of the research. So that would be the one of the software you can use for this research. I'm sorry because I have this background noise. There's a construction going on in the.
Yeah, I kept wondering because like I know it's quiet here and nobody else has their mic on, so it must be at Dugwon Seo. Usually when I have meetings, the landscapers show up. That's kind of typical here. But all right, yes, Rex is saying wonderful conversations. I agree. There's I always learn a lot at these brown bag lunch. And thank you. I think Georgina had to go to a faculty meeting in her department. But thank you to Dugwon. It was very interesting, very informative. And, I'm very happy to have had all of you here, and please mark your calendar for the next brown bag. Again, I had it up earlier, but some of you, I think, came in a little later. The second brown bag lunch will be on October 21st. It's also during club hours. And that will be Kat Griffin from Art and Design and Mercedes Franco from the Math Department will be speaking at that one. All right. And UR Day, anybody who's working with students, you'll be getting more information about that, the virtual UR Day. I'm still trying to figure out virtual stuff, so hopefully we can pull that off without too much of a hitch. We'll be counting on our reps quite a bit, and please fill out the survey if you're working with students that you got from Office of Academic Affairs. It's just, I think, 3 questions. How have you, transitioned to remote undergraduate research? We'd really like to just find out how people are doing with that. All right.
Joan?
Yes.
Go ahead.
No, go ahead. I'm finished. Question?
Sorry, I was just gonna, yes. I think I lost that email, the survey. I don't even remember if I have a vague recollection of filling it out, but everything is such a jumble right now that like, I can't remember, honestly. Is there any way to get that email again?
Yeah, let me check. I think you did fill it out, Jeff, but I can look. If not, I'll just send it just to you. We did.
I should have a camera running on me at all times.
And then we also asked the reps from each department to share it as well.
Okay.
Thank you. But I'll check. I'm pretty sure I saw your name there though, but I'm not 100% sure.
Thanks.
Okay, no problem. I appreciate you caring enough to ask to have it sent again.
Thanks.
Hi, Joan. And I forgot. Did we settle on the format for the UR Day presentations, whether it was going to be a poster style or video?
I think we're going to give an option for both because some people already have posters, and then other folks can do PowerPoint presentations. So we had a planning meeting on Monday where we started talking about that and kind of have approximate dates for, when we'll call for abstracts and submissions and all of that. But we're going to speak to, I don't know how many of you attended the CRIS symposium in the summer, but they did an online symposium and everyone who did attend thought it was extremely well done. So we're going to meet with Ron Nerio from CUNY, who's in charge of the, that symposium, and get some ideas about, about how to do that. But so they had like a main room where the introductory stuff occurred, and then the sessions were done in breakout sessions. They were recorded, right, for the most part, and then they did have a couple that were where they asked the students to present live, which I don't think we're going to do that. So there'll be recorded presentations, but at the time, it'll be at a scheduled time, and then the student will be there live to answer questions. So the presentation itself will be recorded, but the student will be able to answer questions live. And so, as this is being planned, we'll certainly share out more information with you. Well, we should have, I think we'll have the dates and, when we're going to call for abstracts and stuff settled before the research committee meeting next week. So, just be patient.
Okay, thank you.
Virtual world. It literally took me like an hour last night to figure out how to put that background there. So that's what we're dealing with. But I won't give up. And I've got a lot of other people are working on it as well with me. So we're going to make it happen, and it will be good.
So John.
Yeah.
I just wanted to share something that is still kind of in the books, but or brewing, but probably based on the fact of all the movement towards, racial equity or whatever. There are some schools who have reached out to us to be able to collaborate. So we know of UPenn and we know of NYU. So we are kind of having talks to find out what would be the best venues to do that. But it's something that I think as soon as we know a little bit more, we would be more than happy to share about how it could be implemented. And that would open some other doors for people who are interested in doing research or exposing their students to things like that.
Right. That could be something that maybe could occur in a breakout room at UR Day.
Sure. I just
talk more about that.
We do know that we are meeting with people at UPenn and also at NYU, and it's interesting because it's kind of coming from them, and so that's something that it's a little bit of a change, and I think it could be something useful for our students and for our faculty too.
Absolutely.
I just wanted to let people know.
Okay.
All right. Thank you.
All right, guys. Anything else? If not, I'm gonna have us sign off, and well, I'll see some of you at the research committee meeting on Friday. And if not, you'll be receiving more information about the plans for UR Day very soon. All right, and thanks again to Georgina and Dugwon for good talks. How do we do that clapping thing? That's a reaction, right? See, I'm learning. There we go. Everyone give a round of applause. Or you can give a thumbs up too. Those seem to be my only options. What if you don't like something? You don't get to say that? I guess not. All right, guys. Thank you again. Hope to see you all soon, and everyone stay safe and well.
Thank you, Joanne.
Thank you. Take care.
Bye, everyone.
Bye-bye.
Bye, everyone, and hello, everyone. This was very nice.
Hello there.
I really thoroughly enjoyed this. It was very good.
Yeah, it was very nice.
Very nice, yes.
These are always
Such
nice.
interesting projects. I mean, amazing.
There's so much going on, like, right? I would say on our campus, not right now, but you know what I'm saying. And we don't know a lot about it.
Yeah, and you know, Georgina's, I mean, such simple observations and making them into hypotheses and
Hmm.
the experimental, the scientific method into place, just amazing. Just
Absolutely, for a very applied, need. Like,
hands-on, applied, current, you know,
thing
and
with
then
the thermometer, I always wonder, don't I always that I feel like I have a fever, my ear thermometer says 100, but I always feel like it's actually higher than that. So I'm interested to see what
and
they,
Dugwon's, I could imagine what Rex was saying, because in the debate yesterday, the question was asked, like, do you believe in the science behind the climate change?
Mhm.
You know, the science is there. There's
Right.
no point in believing or not believing. The science is there,
Yes.
the facts are there.
Well,
We
not
as
him. He
teachers,
says
just
he
have
says that
people
science.
just present the facts, and
Yeah.
students make their informed decisions. That's what they have to do, make their informed decisions.
Hopefully, if they're not getting bullied into thinking otherwise. But
Yeah.
that guy says science doesn't know. I know. I
Yeah.
know the fires are going to go. It'll
And
be
the
cool.
management
Go away.
includes
Science doesn't know.
picking up all the twigs and the leaves and the dry leaves. What, you're going to clean up the forest now? You're going to go into the forest and clean up and pick up the dry leaves? I mean, that's what is management.
I did not
Anyway,
watch last
let's
night.
not
I
go
think
there.
I've suffered enough this year. I
But this
did.
was
I
great,
didn't
guys.
have the strength for it.
It was very nice. Take care.
All right. Yes, we'll talk to you all soon. Like the biologists are the last people standing here. I'll have to get you guys to talk too. I'm coming after you. Our researchers.
Take
All
care.
right. Take
And
care,
you have
guys.
to teach me how to put that image in the background.
Oh my God, you haven't. It took a long time, and honestly, I was like trying so many things. I'm not even sure I know what I did, but I could.
Looking at that image, I want to go to her college.
Me too.
Yeah.
But I don't. She hasn't messaged me yet today. I think it was too cloudy, but there were things in the parent group that they should be able to see the northern lights where they are.
Oh
Which
my
I know.
goodness.
I was like, I will be so jealous because
Yeah.
that is on my bucket list.
Yeah.
And if she gets to see them before me, I'm not going to be too happy. But anyway.
All right. Take care. Bye,
Yeah,
everybody.
we'll talk soon. Take care.
Bye.
Bye.